Hello, this is Length Paper Review, and today I'll be looking at staRt, enhancing speech treatment with web-based real-time biofeedback. So this is a super cool project. I think the paper right now, as I'm recording this, is still in pre-publication, but the app already works, and it looks pretty complete to me, so I'll be talking about it anyways. These are the authors. I assume they're pretty cool. So why are they starting this project? The main reason is that pronouncing the American English R is hard. That's why R is capitalized in staRt. Articulation is complex and varied. I think there's around 5 main ways to articulate it, and these are all like for competent speakers. So these are all correct ways to articulate the R. This is why for children, as they're developing and learning the English language, usually they'll perhaps mispronounce R, and they'll be learning the other sounds first, and they'll acquire and properly get the R sound later. And it's cute when they say stuff like that. But as people get older, they should hopefully grow out of it. But if they don't, that's called residual speech sound disorder. And at least for there doesn't really seem to be any super easy or effective treatment. So this is really frustrating for both the patients and the medical professionals that are helping them. So the way that staRt tries to fix this, and one way to help with many different problems, is biofeedback, which is using tech for better awareness of one's body with the goal of helping gain control. Technically, just having like a heart rate monitor on your smartwatch is biofeedback, but it can also be like sensors to measure muscle activation or something like that. It's been shown to help with chronic pain, anxiety, and incontinence, and a lot of other things in certain ways. For example, with anxiety, if someone has really bad test taking anxiety, they could have a simple heart rate monitor that says, well, when you're taking a test, your heart rate goes up, so you can they can see the direct effects, and that can help them figure out ways to deal with that. And this is especially relevant for speech. So in this case, the biofeedback is visual. It's going to pop up. It's an app that tells you what you're doing on your screen, and these visuals provide a clear and easy way to the client so that they can know what exactly they're outputting at the moment and what they want to be outputting, their targets. People can sometimes tell when their R's don't sound right, but if they can actually see what exactly is going on, it's a lot easier. The visual biofeedback intervention idea is motivated by motor learning research with the idea that speech articulation counts as a motor skill. Visual biofeedback has previous work on it, which from electropalatography, which displays the location of the tongue on the palate. staRt, on the other hand, displays the output sound, which is important, which is good because there are multiple ways to articulate R, and it's a quite complex sound in the mouth. So palatography might not work super well for this. But electropalatography is super cool, so I'm going to talk about it briefly. So basically, they make like a retainer that goes on the palate of mouth on top. And inside that, there's a bunch of little electrodes. And whenever your tongue contacts those electrodes, there will be a bunch of wires that lead out to a box and then to your computer. And the computer will show where exactly the tongue is contacting those electrodes. And you can see where exactly in the mouth. This is helpful when, for example, someone without any speech issues could record sample sources, and then you can try and copy their actions exactly. Instead of them trying to describe it to you and that not really working. There's a cool video about this. You can check it out. I'll link it in the description. But speaking of links, let's go to try this thing out, because you can just try it in your web browser or on your iPad. It's a free app. So you can just open up the website, and as you speak, you can adjust the auto sensitivity and give it mic permissions. You can see this spectral envelope appear here. And what it does is it shows you the sounds that are coming out of your mouth. Importantly, you can see the formants. Those are the peaks of the wave. So if you say ah, you can see these peaks. So the first and second peaks are, F1 is height, I think, and then F2 is fretness, and then F3 is rhoticity. So for a good R sound, your F3 wants to be around here to the target line, and your F2 needs to be somewhere near here. So if I make an R sound, you can see my F3 is just above the target line, which makes it a pretty R sounding sound. I mean, you can tell me if it sounds like R or not in the, but it's super cool. Definitely try this yourself. It's free and everything. And I'm going to talk a little about technical implementation. So there's a few more features on the iPad app, but the core feature showing visualizing the sound is on the web browser. And what it's actually visualizing specifically is the spectral envelope, and they use linear predictive coding to do this. On the iPad app, there's a standard set of word and syllable targets that the clinician can pop up for the user to say. And for the word targets, if the user is doing well, it will automatically provide harder targets to pronounce. The clinician will have to manually grade and provide feedback in like the form of cute little stars and stuff, which is good for the target audience since a lot of people with RSSD are still quite young. So specifically, what the little cute graph we're showing is a curve in the frequency amplitude plane at a moment of time. And LPC is the algorithm used to guesstimate this thing. The way LPC works is that it assumes the source is a buzzer at the end of a tube with occasional interruptions for like voiceless consonants, and then the filter is the vocal tract, and you can somehow magically figure out the formants by analyzing the linear prediction coefficients of like the previous 30 samples or whatever. Don't know how it works, but this is link paper review, not math paper review. So here we have a spectral envelope in PROT, which we might be more familiar with looking at. So here, spectrogram, and if you take one individual moment of the spectrogram, that's what a spectral envelope is. staRt presents this in a much more easier to use way for like a kid instead of this complex and like kind of scary looking graph. What the authors hope to do in the future is using AI to automatically grade users. Right now, a clinician has to tell the patient how well they're doing. But with an AI, then the clinician doesn't have to stand there all the time, and the patient can just like do it, whenever they have a spare moment. And if they have more therapy, there'll be more learning and more results, hopefully. They also hope to implement the discrete Fourier transform. It's a different algorithm to calculate the spectral envelope. The discrete Fourier transform makes it easier to see some other sounds, mostly like s and sh, and like because of the core assumptions that LPC makes. These are the links. This paper, some stuff you can look at if you want to figure out more. Yep. If you have any comments, any questions, anything I did wrong, put it down in the comments. Thank you.